The periodic table of elements. This is standard 8P12. Explain how the physical properties of elements and their reactivity have been used to produce the current model of the periodic table of elements. And our essential question is, how can you use the periodic table of elements to identify an element's properties? So let's start with Dmitry Mendeleev. Who is he? He is credited with the creation of the modern-day periodic table. He was the first scientist to predict the existence of yet-to-be discovered elements. So you'll see in the video that you're about to watch, but these elements that he predicted existed were eventually discovered. As of 2012, there were 118 elements on the periodic table. So let's watch a short clip about Mendeleev.
The Mona Lisa, and the ice cream sandwich. And the table's creator, Dmitry Mendeleev, is a bona fide Science Hall of Famer. But why? What's so great about him and his table? Is it because he made a comprehensive list of the known elements? Nah, you don't earn a spot in Science Valhalla just for making a list. Besides, Mendeleev was far from the first person to do that. Is it because Mendeleev arranged elements with similar properties together? Not really, that had already been done too. So what was Mendeleev's genius? Let's look at one of the first versions of the periodic table from around 1870. Here we see elements designated by their two-letter symbols arranged in a table. Check out the entry at the third column, fifth row. There's a dash there. From that unassuming placeholder springs the raw brilliance of Mendeleev. That dash is science. By putting that dash there, Dmitry was making a bold statement. He said, and I'm paraphrasing here, "Y'all haven't discovered this element yet. In the meantime, I'm going to give it a name. It's one step away from aluminum, so we'll call it Eka aluminum. Eka being Sanskrit for one. Nobody's found Eka aluminum yet, so we don't know anything about it, right? Wrong. Based on where it's located, I can tell you all about it. First of all, an atom of Eka aluminum has an atomic weight of 68, about 68 times heavier than a hydrogen atom. When Eka aluminum is isolated, you'll see it's a solid metal at room temperature. It's shiny, it conducts heat really well, it can be flattened into a sheet, stretched into a wire, but its melting point is low, like freakishly low. Oh, and a cubic centimeter of it will weigh 6 grams. Mendeleev could predict all of these things simply from where the blank spot was and his understanding of how the elements surrounding it behaved. A few years after this prediction, a French guy named Paul-Émile Lecoq de Bois-Baudran discovered a new element in ore samples and named it gallium, after Gaul, the historical name for France. Gallium is one step away from aluminum on the periodic table. It's Eka aluminum. So were Mendeleev's predictions right? Gallium's atomic weight is 69.72. A cubic centimeter of it weighs 5.9 grams. It's a solid metal at room temperature, but it melts at a paltry 30 degrees Celsius, 85 degrees Fahrenheit. It melts in your mouth and in your hand. Not only did Mendeleev completely nail gallium, he predicted other elements that were unknown at the time. Scandium, germanium, rhenium. The element he called Eka-manganese is now called technetium. Technetium is so rare it couldn't be isolated until it was synthesized in a cyclotron in 1937, almost 70 years after Dmitry predicted its existence. 30 years after he died. Dmitry...
Okay, we're going to stop there with that video, come back here to the PowerPoint. So Dmitry Mendeleev was a huge contributor to the periodic table. So our essential question, whoops, I went backwards, sorry. All right, so here is the periodic table. This is what it looks like. And it's color-coded. We're going to be color-coding one in class so that you've got one similar to this. This is arranged top to bottom, left to right, according to the atomic number, so the number of protons, and that increases as you go top to bottom, left to right. So each individual element on the periodic table is going to have some information in its element box. So this one here you can see is Cl, And all of these chemical symbols will always have a capital letter first and then lowercase letters. Some of them are just a single letter, and that's capitalized, and they can go up to 3 letters. Most of them are 1 or 2. It also is going to have the atomic number, and generally that's on the top or the top corner. That is the number of protons, and again, that's how our table is arranged. And then usually at the bottom you'll see the atomic mass, and that is in AMUs or atomic mass units. And the atomic mass can be found by adding together the number of protons and the number of neutrons. So the periods are the horizontal rows in the periodic table, and again, they increase in atomic number going from left to right. There are 7 periods, so if you start here at the top and count down, you've got 7. Each element in a period has the same number of electron orbitals. So in period 1, they have 1 orbital. In period 2, they've got 2. In period 3, there are 3 orbitals, and so on. Groups are the vertical columns, and again, they're increasing in atomic number from top to bottom. So there are 18 groups going from left to right, and all the elements in the same group have similar chemical properties, and they have the same number of valence electrons. And valence electrons are the number of electrons in the outer shell. So you'll notice as we go through the different families of elements, you'll notice some similarities. So they can be classified into these 10 groups here, starting with the alkali metals, which are all in group 1. And these it's group 1 with the exception of hydrogen. So you'll notice hydrogen is up here. It's a different color because it belongs to nonmetals. The alkali metals in this column here are shiny soft metals. They're malleable, ductile, and good conductors of electricity and heat. They're very reactive, and they all have 1 valence electron in the outermost shell. So in their outer orbital, they'll have the same number of electrons. In this case, it's 1. Alkaline earth metals are silvery, shiny, and relatively soft. They're fairly reactive, so they're pretty reactive, but not quite as reactive as alkali metals. And they have 2 outer valence electrons because they're in group 2. Transition metals is the largest group in the center here on the periodic table. They're metals, they conduct electricity, they have high melting and boiling points, and they have relatively high densities. And as we talk more about density, you will understand more how density is the amount of mass in a given volume. Okay, we have 2 groups called the lanthanide series and the actinide series, and these groups actually fit in the periodic table. You'll see where I've put this red arrow, but what they've done is they've taken the first element in that group, in this case right here, number 57 is lanthanum, and they have named this whole group after that, so that's why it's called the lanthanide series. The reason that they bring it down here is really just to consolidate the periodic table. Otherwise, if this group was moved up here, we would have 2 long rows to about here, and then our transition metals would start, and we wouldn't be able to put that onto a piece of paper. Lanthanide series, these are silvery white in color. The actinide series, again, they're named after the first element in that row, actinium, and I've already explained why, but they're mostly man-made materials, and many of them are radioactive. The other metals, you'll notice they go along this zigzag here in light blue. And these are solid metals under standard conditions, and they're like most metals in that they're malleable, ductile, and they're good conductors of heat and electricity. In comparison to transition metals, they generally are softer and have lower melting and boiling points. Then we have our metalloids, or our semi-metals. They appear to be metal in appearance. They appear to be metal, but they're brittle. Some metalloids, such as silicone and germanium, become electrical conductors under special conditions, and those are called semiconductors. They're solids under standard conditions, and they're mostly non-metallic in their chemical behavior. But again, they have some metal properties, and those are right here on this zigzag. Other nonmetals, so these are ones that didn't fit in another category. They're either gas or solids. They are not good conductors of electricity or heat. They're very brittle in their solid form. They're not malleable or ductile, and they generally have lower densities than metals. The second to last column we have are called halogens. They have 7 valence electrons in their outer shell, and they are highly reactive. And finally, noble gases are the last column. They have a full outer shell of electrons. Helium only has 2, but the rest have 8. Because of those full outer shells, they are very inert, and inert means non-reactive and stable. And this means they don't tend to react with other elements to form compounds. They are gases under standard conditions, and they are colorless and odorless. At this point, if you feel like you understand the periodic table, you've got your guided notes filled out, and you feel good about it, you can end this video. But I do have a video, it's a tour of the periodic table, and just like the other videos, I will attach this in Google Classroom. If you prefer to stop this and watch it there, you might be able to hear it better. But this is a really good video that explains what I explained, but in a little bit of different terms.
Hi, in this video we're going on a tour of the periodic table. Let's start with the guy who is credited with really developing what today's periodic table looks like, and his name is Dmitry Mendeleev. Now, Mendeleev was not the only person who put together a table of the elements, but he was one of the only people who predicted spots within the periodic table that represented elements that had not yet been discovered. And so this was something that was unique to Mendeleev, and that's why Mendeleev is typically credited as the father of the periodic table. So here's how the periodic table is laid out. There's 118 total elements, and they're all numbered, and they're numbered by their atomic number, which is the number of protons. This piece down here, students ask about this quite a bit. The shape of the table, let's just talk about the shape of the table overall is kind of strange. But there's always part of a table that's like separated and put below the table. And why? Well, the truth is that piece fits in right here. But you might see an issue with this. Each box has become very small because the table itself has become very large. And so it's much easier for us to put this on posters if we can keep it to a manageable size like this. That's it. There's really no other scandal involved. It's not like they're the rejected elements. They're just elements that are left to the bottom so that the table can fit on a poster a little bit easier. So element symbols or element boxes on a periodic table, depending on the table you're looking at, can be formatted pretty differently. But no matter what table you're looking at, there's 3 or 4 pieces of information that should be on every table. One is the atomic number of each element. That's always a whole number, and it's just counting up how many protons are in the atom of that element. Another thing that'll be on the periodic table is what we call the element symbol, which is just the 1, 2, or 3 letter abbreviation of the element. One major thing to note here is that the first letter of every element symbol is capitalized. It's got to be capitalized. Any remaining letters, if there's more than one letter, will be lowercase. The third piece of information that's on every periodic table in every box is the atomic mass. Now, this is the average atomic mass of all of the isotopes of that particular element found on Earth. And so we actually just covered a video on calculating atomic mass, so you can check that out if you need a refresher or haven't seen it yet. And then if you're lucky on a periodic table, they'll give you the element name, but that's not always included. It is on ours in our class, but going forward, that's kind of a little bit of a luxury, to be honest. So it's good to know the name and the symbol because they are somewhat interchangeable. In the periodic table, we call rows periods, and there are 7 periods in the periodic table to actually match the 7 electron shells that can surround an atom. Columns in a periodic table are called groups, and there are 18 groups. Elements within a group are very similar. Sometimes groups are called families. Here's an overview of the periodic table. Most of the table is made up of elements which we classify as metals. And in our very next video, we're actually going to talk about what makes an element a metal and what makes it not a metal. If it's not a metal, it's typically called a nonmetal. And notice that the top left element there is a nonmetal, even though it's in amongst all the metals. A lot of the periodic table is what we call nonmetals. And then some of these elements between here are what we call metalloids or semimetals. And they can exhibit characteristics of a metal or a nonmetal depending on the circumstance. So they're kind of strange. The ones in the bottom right corner here, we actually don't know enough about to be able to classify them as one of the types of elements. We've made them synthetically in a lab. That means we just haven't found them naturally on Earth or in the universe anywhere. And they're so unstable that they break down like immediately. So there's not enough time for us to collect information about these elements to be able to classify them as a metal, a metalloid, or a nonmetal. So it's possible that within our lifetimes we'll have the technology to be able to do that, but right now we just don't know a lot about them. Now there are some regions of the periodic table that are so common in everyday items and certainly useful in chemistry to know. These have names to them. With the exception of hydrogen, that very top element there, all of the group 1 elements are what we call alkali metals. All of the group 2 elements, every single one of them, is called an alkaline earth metal. In this middle section here, we've got transition metals, which do some funky things. This section we talked about just on the last slide there are metalloids. Sometimes they exhibit properties of a metal, sometimes they're more like a nonmetal, so it really depends on the circumstances of temperature and pressure. Group 17, all of those elements are called halogens, and then group 18, all of those elements are called noble gases. In this little section here, these, 6 elements there, those are all nonmetals as well. Each of these groups technically have a name, but they're just not as commonly grouped together. And so these are nonmetals. But this bottom piece here, this is called the lanthanide series and the actinide series. And they're named after the elements that lead them off in that period. So this is lanthanum and actinium. And so that's why this bottom piece is just called the lanthanide series for the top row. And then the bottom row is actinide series. So that's it. That's your quick tour of the periodic table. There's certainly more information that the periodic table gives us that helps us, not only in chemistry, but you'll see in a lot of other contexts going forward. So feel free to bookmark this video if you need a quick refresher of what the periodic table is and how it's laid out. It will help.
Okay, don't forget to complete your reflection in the Google form.